This incredible machine is as big as a double-decker bus and weighs about as much as a blue whale. To get it from ASML's headquarters in the Netherlands to Intel's Gordon Moore Park in Oregon took more than 250 crates in 43 freight containers loaded in multiple cargo planes and 20 semi-trucks. This new transistor-making tool will forever change the chip industry. It's the world's first high numerical aperture extreme ultraviolet lithography system, also known as high-NA EUV. It is likely the most complicated manufacturing tool humans have ever built, and it's the result of 30+ years of collaboration between Intel, ASML, and its ecosystem of suppliers.
And so, yeah, seeing that finally arrive at the dock and having seen, over the years the drawings, the animations, how exactly we would ship these components and handle them, and yeah, seeing it all come together was pretty neat.
Lithography machines like ASML's high-NA EXE 5000 project circuit patterns onto hundreds of individual chips on a silicon wafer. The more transistors and components crammed onto each chip, the more capable that chip becomes. The essence of Moore's Law is to deliver this innovation at roughly the same cost every 2 years. High-NA is an evolution of EUV technology and will help continue Moore's Law scaling. ASML's high-NA tool is expected to print features up to 1.7 times smaller than existing EUV tools, and will enable multiple future technology nodes starting with Intel 14A. This tool is so massive it occupies 3 floors in the fab. Its laser is strong enough to cut steel. A beam transport transmits the laser pulse into the high-NA machine, where it slams into tiny droplets of molten tin. Each hot metal droplet only about 1/3 the diameter of a human hair. When that powerful laser, flashing at 50,000 times a second, hits the molten tin, the metal vaporizes into a plasma. This plasma releases light in the extreme ultraviolet range. A collector mirror gathers the EUV light and shoots it to a scanner where it pinballs off extremely precise mirrors that shape the light into a slit that can transfer the patterns of transistors and interconnects. A reticle hosts those patterns and transfers that information through projection optics at a data rate comparable to streaming over 100 movies per second. The projection optics are the key technology that enables high-NA.
The largest mirror is the flattest surface ever devised by man. If you stretched that mirror across the entire surface of the planet, the thickness variation would be less than a playing card.
The high-NA tool will require more than 1,000 electrical and mechanical connections. It will shoot lasers at light speed and heat plasma to nearly 220,000 degrees Celsius, almost 40 times hotter than the surface temperature of the sun.
It's amazing to see how complicated the design is and how amazing it is to see it come to life.
Shrinking transistors to atomic size is one of humanity's greatest technology feats. High-NA will help Intel Foundry deliver never-seen-before precision and scalability in chip manufacturing.